problem in connection, so just managed to connect now.
Good morning, sir.
Good morning, beta. Good morning. I hope you can read me loud and clear.
Yes, sir.
Okay, great. So beta, we had actually covered up the side solving methods, all the 5 side solving methods we had done. Now in these methods, we have seen that by observing a single body, we are able to obtain a single position line. Now, as a navigator, our aim is basically not to find a position line, but to fix our position. So this lecture, we are going to understand how do we obtain the positions using these celestial position lines. For obtaining the positions, we require minimum 2 PLs. So once these 2 PLs are there, then these 2 PLs can be plotted on the chart, and wherever these 2 PLs intersect, that will be the fix of the ship, that will be the position of the ship. But the questions which we get in the examination, these questions are not given in chart work. So you will not have the PLs on the chart which is provided to you, but you will have to make a small portion of the chart on your answer sheet. So this is known as plotting. So we will have to make a small part of the area, the plot of the area on our answer sheet, and then plot these 2 position lines and then find out where our position is. Sometimes they provide us with a graph paper also. So if a graph paper is there, then it can be used for plotting. Otherwise, our simple answer sheet, plain paper or a ruled paper, a simple answer sheet, we can use to plot the area and find out the position of the ship. So this is what we are going to see now in this lecture. I am going to show you a video, and in that video we will see first the concept of plotting and then the method or procedure which we follow in plotting. Now in plotting questions, there are basically 2 types of questions. One is when both these sides are taken at the same time. It is known as a simultaneous observation. These are comparatively simpler questions. So first we will see these simultaneous plotting questions, and once we are done with them, then we will move on to the staggered plotting question. Staggered plotting question means that both these positions are, or position lines, are obtained at different times, and we have to combine them by transferring one of the PLs to the second position line time. So once we are clear about the simultaneous plots, then we will move on to staggered plots. So let me set up the video and we will go into this topic. Before I do that, any doubts or queries in your mind? Okay, so silence tells me all good. So let's get set and see this simultaneous plot.
Work wherein we plot position lines and position circles to obtain the vessel's fix. It's exactly the same way as in chart work.
But I hope you are able to hear the audio and see the video.
Yes, sir.
Yes. Yes, sir.
Okay, beta, great. So let's continue with simultaneous plots.
Only difference being in chart work, we have the latitude and longitude scale printed on the chart. We have the compass roses to give us the directions, and hence we have everything available there, and we just measure the parameters on the respective scales and we do our plotting. In these questions, when we are talking of graphical representation without chart, then obviously we'll have to either use a graph paper or we'll have to do on a plain sheet taking a suitable scale. So let's run through the steps involved in solving these questions. First, we'll have to analyze the information that is provided to us to figure out adequate information so that we can get to know whether it is giving us two position lines, or is it going to give us two position circles, or else maybe one position line and one position circle. Needless to say, as the title of the video suggests, both the observations have to be for the same time, that is simultaneous observations. From the information that we obtain, we identify for position line, what is significant for position lines is we'll have to identify a position through which to draw the position line, irrespective of whether it's a terrestrial PL or a celestial PL. We'll have to identify a position through which to draw the PL and the direction of the PL. For position circles, we'll have to make effort to identify the center of the position circle and the radius of the position circle.
Now, beta, you see the methods which we have done, Marpas, long bicron, intercept, X meridian, and Polaris. In all these methods, we have found out these two things: the position through which the PL passes and the direction of the PL. In every method which we did, we were able to find out these 2 points, these 2 pieces of information. So when you have this information, you are able to plot that PL on the chart or on your graphical plot. So this is what we require. Now, in some cases, they may also give you position circles. Position circles could be ranges of a certain point from land. So they may give you a lat long where a certain lighthouse is, and they may tell you you are so much distance away from that lighthouse. So we combine the position line with a position circle in plotting. If 2 PLs are given, then wherever those 2 PLs intersect will be the fix of the ship. If 1 PL and 1 position circle is given, then wherever these 2 intersect will be the fix of the ship. So we will see once we understand the concept going into the questions how this information is provided and how is this plotted on the graph or answer sheet.
Now, to be able to mark parallels of latitudes, meridians, and mark of positions and distances, we first draw one of the parallels of latitude and one of the meridians that we know in the question. And these ones drawn first act as reference for marking the remaining parallels of latitude and remaining meridians. Plot other parallels of latitude and distances on the plot, we choose an appropriate scale. Obviously, we should be choosing the largest possible scale in a given scenario. We know that the latitude scale or scale of latitude and the scale of distance are same. Why? Because 1 minute of latitude represents 1 nautical mile. Plot other meridians with respect to the reference meridian just discussed above. We need to find out what shall be the east-west spacing between the 2 meridians. Now, this east-west spacing between the 2 meridians shall depend between the d long between the 2 as well as the latitude. Why? Because we know that meridians have maximum separation between them at the equator and they all converge at the poles. So the east-west distance between them we all know is called as departure. So when we plot the meridians, we'll use the scale that we have chosen and will separate the meridians by a distance equal to the departure in the latitude for which the plotting is being carried out. Departure is obtained with reference meridian and the meridian to be plotted from their D long and latitude. And which formula do we use to get the departure? It's the parallel sailing formula, which is departure upon D long is equal to cosine of latitude. Now, once all the parallels of latitude that are required are marked on the plot and also the meridians, then we can use them to identify on the plot the position through which to draw the position line and the center of the position circle.
Beta, all clear up to here? Any doubts in any of the points, Beta? Okay, all right.
PLs and PCs can be plotted as they shall be simultaneous observations. So the intersection shall give us the fix. Now, using the scale of the plot, the delat of the fixed position can, from any of the parallels that is plotted on in our plot, can be measured, and that delat can be applied to the latitude of the parallel from where it is measured, and that shall give us the latitude of the fix. Likewise, east-west distance of the fix can be measured from any of the meridians which is plotted at identifiable and using the same scale as the scale of distance. And this shall be the departure between the meridian from where it is measured to the meridian of the fix. This departure can be converted into D long using the parallel sailing formula. And once the D long is obtained, the D long can be applied to the longitude of the meridian from where the departure was measured, and that shall give us the longitude of the fix. So this way, the fix having been identified on the plot, its coordinates can be obtained in latitude and longitude. Let's apply our learnings to an example.
Okay, so basically, Beta, we have seen that in these questions, first of all, we have to see what is the information provided. The information will be exactly same what we have calculated in sites. They will tell us a position through which the PL passes. They will tell us the direction of the PL. Using that, we can plot the position line in our graph or plot. So once the position line is there, so you have two of them. Wherever they intersect will be the fix. Now, since we are not on the chart, if we were on the chart, we would be able to read the lat long straight away. We are on a plain sheet of paper or a graph paper. We will have to measure the delat and the departure, convert it into D long, and then find the fix of the vessel. So we are able to now apply this in actual questions. You can see we have this question on the screen now. Let's try to understand and do this question. Now you see in DR 50 degree 10 minutes south, 140 degree 40 minute east, star X observation gave an observed long 14036 east, azimuth 075. So you can see they have given us a long by Crone information. Now, can you tell me, Beta, which is the position which we will use to plot the PL, latitude and longitude?
Sir, 5010 south and 14036 east.
Very good. So DR latitude and the observed longitude is what we are going to use. And the azimuth is given to as 075. So we know perpendicular to the azimuth will be our PL. So we have all the information to plot the first position line. Now let's see ahead. At the same time, star Y meridian altitude gave an observed latitude of 5014 south. So this one is simple. If you have a observed lat from a Marpas observation, that latitude is your fixed latitude and that latitude is the PL also. So we need to find the vessel's position now. So any doubt in the question, beta? Okay, great. Now let us see how do we plot it on the graph or the plain paper.
In DR, 50 degrees 10 minutes south, 140 degrees 40 minutes east. Star X observation gave an observed long 140 degrees 36 minutes east. Azimuth 075 degrees true. At the same time, star Y meridian altitude gave an observed latitude 50 degrees 14 minutes south. Find the vessel's position. Now, before we proceed any further, it's important to identify the methods deployed for solving the site of star X and star Y. I'm sure we can all figure out that star X has been solved using long bicron, and in such case, the PL shall be drawn through DR lat and observed long. Direction of the PL perpendicular to azimuth. As far as star Y is concerned, it's a meridian altitude observation. So the PL shall be drawn through observed lat and DR long, perpendicular to azimuth, but in this case of meridian altitude, the PL shall be specifically east-west, and hence it will coincide with the parallel of latitude of the observed lat. Now, having identified the processes deployed for solving the sites, we proceed ahead with the plotting. We have the DR lat coming up on the screen. We have the observed lat now the D lat from DR lat to observed lat is 4 minutes south. This information shall be used to plot these two parallels with respect to one another. Direction of PL of X, as already said, it will be perpendicular to 075 degrees to the azimuth, so shall be 165 degrees to 345 degrees. Direction of PL of Y shall be east-west, that is 090 degrees to 270 degrees true, being a meridian altitude observation and solved by latitude by meridian altitude. Now we come on this side. We have this DR latitude, parallel coming out here. Then we decide on the scale that we would like to use.
Now, beta, the first latitude which you have plotted on the sheet, any line can be taken as your DR lat 5010 south. So you could choose any line on the graph as your DR lat. Now, it is always better to first make a rough diagram in your answer sheet on the side. Rough diagram gives you an idea where do you need to mark that particular latitude. Like somebody could have marked this DR lat 5010 towards the bottom of the diagram also. But if you mark it toward the bottom, you will see that it is possible that the final plot may not come on your answer sheet. So it is always better to make a small rough diagram on the side. It will immediately give you an idea whether this latitude should be plotted on top of the sheet or at the bottom of the sheet. So once it is done, then you can go ahead. We have plotted the first latitude, that is the DR lat 50 degree 10 minutes south.
We'll use, as far as graph in the background is concerned, one big box as 1 centimeter. If without graph, we can take 1 centimeter as 1 minute. So the observed lat has to be 4 minutes south of the DR. So we go 4 minutes south, D lat 4 minutes south, and we draw the observed parallel of latitude out here. Now, in this case, the latitude that the meridian that we shall need would be the observed long. So we draw the observed long. It's drawn out here. Now we all know that for star X, the PL shall be drawn through DR lat and observed long, that is this point. And direction as already calculated as 165, 345. We have this PL for star X coming up here, passing through this point. PL for star Y is going to coincide with the observed parallel of latitude. So here is the PL for star Y, which you can say should have been drawn through observed lat and DR long. But since it's east-west, so it doesn't matter whether DR long is marked or not. Now the two PLs being for the same time, they intersect here. So this becomes the fix of the vessel. And what do we see? The latitude of the fix is same as the observed lat. And this distance is the departure of the fix from the observed long. So we see that the departure is 1.1 minutes east from the observed long. So we come this side for calculations now. Fixed lat is same as observed lat, 50 degrees, 14 minutes south. Departure, read off from the plot using the same scale out here. From observed long to fix is 1.1 minutes east. We convert this departure into D long by using the cosine parallel sailing formula for latitude 50 degrees 14 minutes, and we get the D long as 1.7 minutes east. This D long we apply to the observed longitude, and that was 140 degrees 36 minutes east. When we apply a D long of 1.7 minutes east to it, our fixed longitude becomes 140 degrees 37.7 minutes east.
Okay, so beta, the full question is plotted now and we have obtained the answer. Just have a good look at the plot as well as the working, and let me know if you have any doubt at any of the steps.
सर जब इसे हम चार्ट पे प्लॉट करेंगे तो हमें डिपार्चर लेने की जरूरत तो नहीं होगी ना, तब तो हम डायरेक्ट डी लॉग ले सकते हैं ना चार्ट से लॉन्गिट्यूड।
बिल्कुल बेटा, अगर ये क्वेश्चन आपके चार्ट पे बेस्ड आएगा तो फिर तो बहुत ही सिंपल हो जाएगा, आपको डिपार्चर लेना नहीं है, आपको सीधा डी लॉन्ग चार्ट से रीड कर लेना है. बट as far as our paper is concerned, this question comes as question number 5 or 6 of your paper, and it is not related to the chart. So we need to draw this on our answer sheet or the graph.
ओके सर।
ओके
सर एक चीज और सर जो अपना ऑब्जर्व लोगे हम कहीं भी ले सकते हैं या पर्टिकुलरली मतलब वी कैन टेक एनीवेयर ना?
एनीवेयर बेटा, यू कैन टेक इट एनीवेयर. ओनली थिंग सिर्फ इस चीज़ का ध्यान रखना है, जैसे इस पर्टिकुलर केस में आप देखो हमने ऑब्जर्व लॉन्ग यहाँ पे लिया है एंड यू सी द फिक्स इज कमिंग स्लाइटली ईस्ट ऑफ इट. अब अगर यही ऑब्जर्व लॉन्ग को आप राइट साइड में कहीं ले लेते तो हो सकता है कि आपकी जो फिक्स है वो आपकी आंसर शीट से या ग्राफ पेपर से बाहर चली जाती.
राइट
सिर्फ इतना ध्यान रखना है कि आप इसको ऐसे लो दैट जो भी फिक्स है वो आपकी आंसर शीट पे या ग्राफ पे कंफर्टेबली आ जाए. इट शुड नॉट हैपन कि आपने एक ऑब्जर्व लॉन्ग लिया एंड लेटर ऑन यू केम टू नो जो फिक्स है वो तो एमएमडी के टेबल पे चली गई है. सो यू विल नॉट बी एबल टू स्टेपल इट विद योर शीट. सो वैसा नहीं होना चाहिए,
अंडरस्टूड.
अदरवाइज यू कैन टेक इट एनीवेयर.
ओके सर.
ओके, और बताओ बेटा, और डाउट्स?
तो सर इसने तो डायरेक्ट फिक्स दे दिया, तो ये डिपार्चर डीलाइट क्यों लिया हमने? तो डायरेक्ट जब ये दोनों प्लॉट कर दिया था तो फिक्स तो आ गई थी ना पोजीशन.
बेटा फिक्स हमारे प्लॉट पे तो आ गई थी, बट उसका लेट लॉन्ग नहीं मिला था ना हमें. हेलो.
हाँ सर ठीक है.
हाँ बेटा, अंडरस्टूड. ओके, और बेटा और डाउट पूछो. ओके, सो शैल वी मूव अहेड बेटा?
यस सर.
गुड, ग्रेट.
So the coordinates of our fix obtained through plotting would be then 50 degrees, 14 minutes south, 140 degrees, 37.7 minutes east, and it's here that we have the fix of the vessel. I'll also take you quickly through same plot. It was done without a graph paper. The same plot, same steps. I don't think they need any further explanation because it's a repeat. But only thing is now plot is being done on a plain sheet. And you can see how the plot is coming up. The two parallels have come up. We have the observed long meridian coming up. We have the PL for X. We have the PL for Y. We have the fix being identified here. We have the departure here, and then same calculations as the earlier discussion being carried out to get the coordinates of the fix. So if you do not have a graph, then your plot shall be somewhat like this. Please do not forget to declare your scale in the plot. It's very, very essential. So the whole idea of showing this one was that if you do not have access to the graph paper, you could have your plotting done this way, the way you see it on this particular slide, which is on display right now. One more example.
So moving on to the second example now, beta. Again, a simultaneous plot. And now if you see, we have one long bichrone site, star X, having a azimuth of 220, observed longitude 17955 east. And the second site of star Y is a intercept site. So we have the azimuth as well as the intercept given to us. The DR position is also available. So we have all the information to plot these two position lines. So let us see now how do we solve this.
Using DR 12 degrees 20 minutes north, 180 degrees, simultaneous observations of two stars gave following results. Star X, azimuth 220 degrees true, observed long 179 degrees 55 minutes east. Star Y, azimuth 305 degrees true, intercept 3 miles towards. Find the vessel's position. I'm sure star X, which is a repeat as far as the process of deployed for solving it is concerned, has been solved by long bichrone, as discussed in the previous case also. So therefore, for star X, the PL shall be drawn through DR lat and observed long. Direction of the PL shall be perpendicular to the azimuth. Star Y, which gives us intercept, has been then solved by intercept method. The PL shall be drawn through ITP, intercept terminal point or intercept terminus point, and the direction shall be perpendicular to azimuth. Having identified the methods deployed and the positions through which to draw the PL, we can proceed further. We can see on the graph, we have drawn DR lat and DR long and assumed a scale out here. Obviously, these have been placed keeping in mind the question so that other meridians and other parallels of latitude, if required to be plotted, they have enough space to be plotted on the graph. Now, DR long is 180 degrees. Observed long by solving star X site is 179.55 minutes east. So if I have to plot observed long with respect to DR long, which has already been plotted, then the D long between the two, it's the D long between the two, which is 5 minutes west from DR to observed long. That means observed long shall be plotted west of the DR long. But the spacing has to correspond to departure. So we find the corresponding departure, and the departure is found to be 4.9 minutes west. We also identify the direction of the PL for star X, which is perpendicular to its azimuth, direction being 130 to 310. And likewise, direction of PL of Y, perpendicular to azimuth of 305 degrees true, and direction being 035 degrees to 215 degrees true. So now using this departure between the two meridians, we plot the observed long. So here is the departure to the west, 4.9 miles, and here is the meridian for the observed long. Now wherever the DR lat intersects the observed long, this is the point through which the PL for star X has to be drawn, and its direction is 130 to 310. So here is the PL for star X, which comes up on the plot. PL for star Y would be drawn through ITP. So first we draw the azimuth through the DR. Azimuth of star Y is drawn through the DR. Now intercept is 3 miles towards. That means it will be 3 miles on this line towards the body. We mark off 3 miles here. This green line showing up here measures 3 miles. So this is the point which is the ITP. Through this point, we draw perpendicular to the azimuth and we get the PL for star Y. Since both the PLs are for the same time, therefore this is where the fix is.
So beta, up to here, any doubts in the mind? Have a good look at the plot and the information. Let me know if you have any doubts at any point.
ग्राफ पे हम लोग डिपार्चर प्लॉट करते हैं ना, इसका एक बेसिक यही है.
Say again, ask again, beta.
सर ग्राफ पे डिपार्चर प्लॉट करते हैं ना हम लोग.
Yes, beta, exactly. Always remember that we always plot the departure on the graph, never the D long. Okay. और कोई डाउट बेटा? Okay, so let's proceed ahead. We have the fix on the plot now. We just have to find out the latitude and longitude of the fix.
We read off the D lat for the fix from the DR lat, which is 0.7 minutes south. And likewise, we also read off departure, which is 0.8 minutes east of the observed long. Using this D lat and departure, we come on this side. We have the DR lat. We know the D lat of the fix from the DR lat. And we get the latitude of the fix as 12 degrees 19.3 minutes north. We have the departure of the fix from the observed long, which is 0.8 minutes east. We convert this departure into D long. So D long comes to 0.8 minutes east. So that means longitude of fix is 0.8 minutes east of the longitude, observed longitude. Observed longitude being 179 degrees 55 minutes east. The longitude of the fix is then 179 degrees 55.8 minutes east. And hence, coordinates of the fix are 12 degrees 19.3 minutes north, 179 degrees 55.8 minutes east.
So we have found out the latitude and longitude of the fix also by getting the D lat and departure from the plot. So any doubts in this question, beta?
सर
हाँ बोलो बेटा.
सर जैसे अभी हमारा अगर लॉन्ग बाय क्रोन का रहता है, अगर जैसे प्रीवियस क्वेश्चन में एक था, तो वहां पे सर हमको ये डीआर लॉन्ग और डीआर लेट पहले प्लॉट करके फिर डिपार्चर कैलकुलेट करके फिर ऑब्जर्व लॉन्ग प्लॉट करने की जरूरत नहीं थी, डायरेक्ट हम लोग ऑब्जर्व लॉन्ग प्लॉट कर सकते थे ना?
यस वी कैन बेटा, वी कैन.
Okay.
अगर आप लॉन्ग बाय क्रोन साइड को प्लॉट कर रहे हो तो हमें उसमें डीआर लॉन्जिट्यूड नहीं चाहिए, सिर्फ ऑब्जर्व लॉन्जिट्यूड चाहिए. So you can do that with DR latitude and observe longitude.
तो वहां पे अपना डिपार्चर और डी लॉन्ग से जैसे इस क्वेश्चन में कैलकुलेशन है वैसा करने की जरूरत नहीं है.
Not required beta, unless you need your DR longitude for some other site. ओके
Okay.
जैसे इस केस में
Okay.
आपको इंटरसेप्ट प्लॉट करने के लिए तो dr लॉन्ग चाहिए होगा ना, सो इस क्वेश्चन में तो ये
Yes, sir.
मैंडेटरी बनेगा।
Okay. Okay, sir.
ओके और बेटा और कोई डाउट? ओके ग्रेट, सो शैल वी मूव ऑन फर्दर बेटा?
Yes, sir.
Okay, if you want you can take a screenshot of the plot and you can practice these questions before you go on to the book questions or the past papers questions. You can practice them, you have the solution in front of you, so you will be able to check your working immediately. Okay, so let's proceed ahead then. Let's see one more example.
Now, if you do not have access to the graph paper, the same plot shall appear the way you can see on a plain sheet here and drawn to a scale that is chosen. And that's how your plot shall appear on a sheet in the absence of being plotted on a graph paper. Let's have one more example then. On 15th June 1992 at GMT 12 hours 05 minutes, the true altitude of the sun was found to be 89 degrees 55 minutes. At the same time, a point of land in position 23 degrees 26.5 minutes north, 001 degrees 15 minutes west, bore 320 degrees true. Find the position of the vessel if the sun passed north of the observer.
Okay, now beta, for this particular question, we need to understand a concept of high altitude observations. So I will have to first explain to you what is a high altitude observation. You see the altitude of the sun is 89 degree 55 minutes. So this is a very high altitude. It's just 5 minutes away from your zenith. It is almost overhead. So we will first see what this high altitude observation is and how it is plotted, how a high altitude observation is plotted. We have not seen that in our PL methods. In all the PL methods, the altitude was not very high. Altitude was a intermediate altitude. So we will first see that and then we will come back to this particular question. So now you tell me, shall I go ahead with the high altitude of the method? It is just about a 5 minutes topic. We have about 5 minutes. Or you want to do it in the next class?
नहीं सर कर लेते हैं आज।
Next class.
Next class, sir.
Okay, all
Next
right.
class.
ठीक है बेटा. So next class I'll explain you the high altitude concept and then we will do this particular question on plotting, and with this we will cover up the simultaneous plot. So ठीक है then बेटा. Any other doubt till now?
सर वो साजन सर को बोल देना वो लिस्ट डाल दें एक बार।
बोल दिया बेटा, ऑलरेडी बोल दिया, वो डाल देंगे आपको. Okay, all right then. So see you in the next class beta. Till then, bye bye.
Thank you, sir.
Thank you.